So hello everyone, welcome to today's class. In this class what we are going to learn is the calculations of integration. I hope you have seen the last lecture that was about its meaning, like what is the real meaning of integration, and in this class we will be learning about calculations of integration. Like once you have got the meaning, how will you integrate that? For example, if it looks like integration of x raised to power n dx, how will you integrate this function? Or if you are given with integration of sin x dx, how will you integrate that? ये हमने समझ लिया है कि what does this mean? This is basically the function that you are integrating. And what does this mean is the part for which this function is assumed to be constant. Changing this much value doesn't change the function significantly, for which this function is constant. So we will have certain rules and we will apply them step by step. Like for the first step, you will apply this first step to all integrations. Or if you are like succeeding और आपका integration complete हो गया first step से, then it's fine. Otherwise you have to move to the second step. So basically integration is the reverse process of differentiation. Reverse process of differentiation. What does this mean? This means that if you have learned the formulas for differentiation, they all will be working for integration also. For example, we have like differentiation. Now I am talking about differentiation. Please see this very carefully. Like if we know that differentiation of e raised to power x, which is you write it as dy by dx, is e raised to power x only. So the integration of e raised to power x will be also e raised to power x only. Let's take one more example. This is a bit confusing क्योंकि दोनों same ही है. Like if you say y is equals to sin x and you differentiate sin x like dy by dx, so differentiation of sin x is equals to cos x. है ना, ये अपने को differentiation से याद है. And in this case, the integration of cos x will be equals to sin. So these are kind of reverse process. This is your first step to do always. Just check if the given function was differentiation of something. Let's take one more example. Let's say we are given with integration of sec square x dx. So just remember a function जिसका differentiation sec square x था. तो we know that if y was equals to 10x, तो 10x का differentiation sec square x होता था. Right? अगर अभी आपको याद नहीं है, you can see them from the formula sheet जो पीछे था अपने पास. So integration of sec square x will be 10x. So you will write it in this way, that this integration sign and this integration is equals to 10x. Let's take one more example. For example, if you are asked with integration of 1 upon x dx, तो just think 1 upon x किसका differentiation था? तो I think we have a function which was log x, and if you differentiate log x, which is dy by dx, the differentiation was 1 upon x. So integration of 1 upon x will be equals to log x, and you will write it in this way. Are you getting my point? किस तरीके से वो reverse process है? Let's take one. Great. Let's take one more example. If you are asked with integration of cos x, then just think that if you have अ फंक्शन cos x, ऊपर हमने sin x का किया था, डू यू रिमेंबर? तो sin x का डिफरेंशिएशन cos x है, तो cos x का इंटीग्रेशन कितना हो जाएगा? sin x। ये हमने ऊपर कर लिया है, दिस इज सिंपल। ठीक है, देर इज नो प्रॉब्लम विद साइंस। फॉर एग्जाम्पल पॉजिटिव और नेगेटिव साइन है तो वी कैन टैकल इन दैट वे ओनली। किस तरीके से? लेट्स से कि वी हैव अ फंक्शन which is like we have a function, please, नहीं, for integration sin x का जो डिफरेंशिएशन था that was cos x, तो cos x का जो इंटीग्रेशन होगा that will be sin x only। Next step is if you are asked for, let's say, integration of sin x dx. What this will be? Like you have a function y is equals to cos x, तो इसका डिफरेंशिएशन कितना था? माइनस साइन एक्स। नाउ वी नो दैट कि माइनस साइन एक्स का इंटीग्रेशन cos x होता है, तो यू कैन से कि इधर मैं एक माइनस साइन लगा दो, है ना? अप्लाइंग नेगेटिव साइन टू ईदर साइड ऑफ द इक्वेशन डजंट चेंज एनीथिंग। क्या आप उस माइनस को इधर लगाओगे या उसे इधर लगा दोगे तो दैट इज सेम। सो इंटीग्रेशन ऑफ साइन एक्स विल बी माइनस कॉस। कंफ्यूजिंग हो रहा है थोड़ा? एक बार इसका एक छोटा सा चार्ट बना लेते हैं, दैट साइन एक्स एंड just a second, I will write differentiation to this side and integration to this side, so that it will be easy for you to learn. So this side we will have differentiation and this side we will have integrations. So sin x का डिफरेंशिएशन cos x, cos x का इंटीग्रेशन sin x, cos x का डिफरेंशिएशन माइनस sin x, माइनस sin x का इंटीग्रेशन cos x, या फिर sin x का इंटीग्रेशन माइनस cos x। दैट वर्क्स लाइक सेम। अभी ऊपर बताया आपको कि मल्टीप्लाइंग टू नेगेटिव साइन ऑन ईदर साइड ऑफ द इक्वेशन डजंट चेंज एनीथिंग। ठीक है, तो इफ यू आर आस्क्ड फॉर sin x ओनली यू कैन से माइनस cos x सिंपली। देन वी हैव 10x, तो 10x का डिफरेंशिएशन क्या था? दैट वाज sec square x, so the integration of sec square x will be 10x. Then we have like let's say log x. You can like learn this for all functions. I am just telling some of them. So log x का डिफरेंशिएशन था 1 upon x, तो 1 upon x का इंटीग्रेशन क्या होगा? log x. For example we have a raised to power x, और a raised to power x का डिफरेंशिएशन था a raised to power x log a. So integration of a raised to power x log a is a raised to power x. We have e raised to power x, which is like the best one. E raised to power x is e raised to power x, e raised to power x is e raised to power x. So these are kind of functions. We have very simplest form of integration, and this can be integrated through like reverse process of differentiation. Have you got this point, like how you have to use? Great. So you must have remembered that the differentiation of x raised to power n was n x raised to power n minus 1. So please see what you have done. You have written this power before और आपने उसमें से 1 subtract कर दिया है. So what we will be doing here is, like if you do integration of x raised to power n dx, what you will do is you will add 1 to the power, क्योंकि डिफरेंशिएशन में आपने 1 माइनस कर दिया था, तो अभी आप 1 ऐड कर रहे हैं, एंड यू विल राइट दिस पार इन डिनोमिनेटर सो दैट जब आपने डिफरेंशिएशन किया था वो कैंसिल हो गया होगा। ठीक है, सो दिस इज काइंड ऑफ द फॉर्मूला फॉर इंटीग्रेशन। This formula is written basically because you will not get the questions in this form, है ना। ऐसे nx raised to power n minus 1 में तो नहीं मिलेगा कि आप उसे वापस इधर ले जाओ। That is why we have learned that formula, although the method is same. मेथड कहता है कि डिफरेंशिएशन में आपने पावर को पहले लिखा और पावर में से 1 माइनस कर दिया, तो इफ यू नीड टू टेक द रिवर्स प्रोसेस, व्हाट यू कैन डू इज just add 1 to the power, क्योंकि आपने 1 माइनस किया था, and if you write it in denominator, so that will cancel out. So let's take some examples based on this. If you are asked for integration of x square dx, please make sure that this variable which is x and this with this element like dx, they should be same, otherwise there is no need to integrate that function. ठीक है, you can say that integration for this function is not possible. So integration of x square dx, and if you will integrate, what is the procedure? According to this formula, you will add 1 to the power, और आपको उस पावर को नीचे as it is लिखना है. That means you have got x cube upon 3. Let's take one more example. If you are asked for integration of 1 upon x square dx, what you will do is you will write it in a better form, which is x raised to power minus 2 dx, and this will be equals to x raised to power minus 2 plus 1 upon minus 2 plus 1, and this will be equals to x raised to power minus 1 upon minus 1, or you can say minus 1 upon x. This is your answer. Let's take one more example. If you are asked for integration of 1 upon x dx, what you can do is, for 1 upon x dx, don't take this 1 upon x as x raised to power minus 1. That is because it is a direct differential of log x. याद है क्या सबको? So this is kind of very good. Great. This is kind of some you can say exception, that this in this formula the value of n cannot be equals to minus 1, and this is because this n is equals to minus 1. If you will write it in denominator, so you will get x raised to power n plus 1 upon 0. उसका अभी अपने को कोई मतलब क्लियर नहीं है. That is why we have used this n cannot be equals to minus 1, and if n is equals to minus 1, then you can integrate using this equation, because n raised to power minus 1 में आपको उसे 1 upon x करना पड़ेगा. Then let's take one more example. We have the fourth one, integration of 1 upon x, और यहां पर 5 लिखा हुआ है इस बार, and dx. Please see this carefully, like how you have to change the form. It will be equals to integration of 1 upon x raised to power 1 upon 5 हो जाएगा, and dx, and this will be equals to integration x की power 1 upon 5 है, when you will take it in numerator, this will be equals to x raised to power minus 1 upon 5 dx. Now this is a simple form to integrate. ये हमने डिफरेंशिएशन में भी सीखा था, like how you have to tackle this root and this power. For example, in the first one I have written 5. अगर यहाँ पर 3 होता तो this would have been 1 upon 3. And if you wish to integrate this, you will get x raised to power minus 1 upon 5 plus 1 upon minus 1 upon 5 plus 1, and this will be equals to x raised to power 1 minus 1 upon 5, that is minus 4 upon 5 divided by minus 4 upon 5. इसे हम थोड़ा और सॉल्व कर सकते हैं, like taking in numerator, this will be equals to minus 5 by 4. just a second, 1, oh sorry, तो plus 4/5 and this will be equals to plus 5/4 और x raised to power 4/4. ठीक है, तो this is how you can integrate those functions in which you have a direct role of x raised to power n. This is kind of the equation जो हमें differentiation में भी मिला था. ठीक है, so this is about using the first form. There is a rule which is like you can integrate the functions if they are in different terms. This is similar to differentiation. Differentiation में भी ऐसा ही था कि अगर अलग अलग टर्म्स हैं तो आप उन्हें अलग अलग इंटीग्रेट भी कर सकते हैं. लाइक इफ यू आर गिवन विद इंटीग्रेशन ऑफ एक्स स्क्वायर प्लस कॉस एक्स माइनस 1/x dx, यू आर गिवन विद दिस, तो आप इन्हें अलग अलग इंटीग्रेट कर सकते हैं. कैसे? यू कैन इंटीग्रेट दिस लाइक x raised to power 2 plus 1 upon 2 plus 1 for the first one. Then cos x was directly differentiation of sin x, तो cos x का जो इंटीग्रेशन होगा that will be equals to sin x. Then minus और 1/x का इंटीग्रेशन क्या होगा? log x. So this will be your final answer. Please don't get confused in case of sin x and cos x. Remember it in this way, जो मैंने यहां पर लिखा है, that differentiation of sin x is cos x, so integration of cos x will be equals to sin x, and similarly differentiation of cos x is minus sin x, so integration of minus sin x will be equals to cos x, or integration of sin x will be equals to minus cos x. Have you got all of these points? So that's great. I hope you can do such type of questions. Then this was the first step that you have to find. But like if I ask you to integrate a function that looks something like this, if I ask you to integrate integration of cos square x dx, so if you wish to integrate cos square x, this is kind of looks like a complicated function, because this part cos square x is directly not a differentiation of any function. ऐसा कोई फंक्शन नहीं था जिसे आपने डिफरेंशिएट किया और डिफरेंशिएशन के बाद cos square x आ गया हो. There was a function for cos x but not for cos square x. So please be very careful while doing integration. अगर जो रियल फॉर्म था, by saying real form, by exact function, like अगर इंटीग्रेशन ऑफ cos x dx है तो we can integrate, but अगर cos square x भी है तो we cannot integrate. Like the function has to be exactly as same as it was in differentiation. Only in that case you can integrate it directly. Otherwise you have to use the other methods. And one thing which is also very important, that is there is no product, division or chain rule applicable in this. Which means you cannot do it like कि यहां पर मैं चेन रूल लगा दूंगा कि उसका स्क्वायर हो गया तो स्क्वायर को पहले इंटीग्रेट कर लेते हैं. देयर इज नो सच अ केस, है ना. आपको जब भी इंटीग्रेट करना है यू हैव टू फाइंड द एग्जैक्ट फंक्शन जिसका आपने डिफरेंशिएशन किया था. अदरवाइज यूज सम अदर मेथड्स जो अभी हम सीखने वाले हैं. तो इफ यू हैव फाउंड द एग्जैक्ट डिफरेंशिएशन तो फिर तो ठीक है, फिर तो इंटीग्रेट हो गया होगा. अगर नहीं है, so the second step is just see if your integration for some function which was fx और आपने उसे इंटीग्रेट कर दिया था और वो gx के इक्वल था. And now what you have done is you have replaced this x by a linear replacement, which is integration of f of ax plus b type. That means in place of x, अगर आपने कुछ लीनियर रिप्लेसमेंट किया, दिस इज कॉल्ड एज लीनियर रिप्लेसमेंट. लीनियर रिप्लेसमेंट बिकॉज जो x का पावर है यू कैन सी वो अभी भी 1 ही है. तो अगर आपने ऐसा कुछ लीनियर रिप्लेसमेंट किया तो द इंटीग्रेशन विल रिमेन सेम. फॉर एग्जाम्पल इट वॉज gx फॉर fx, तो अभी भी वो g ax प्लस b ही रहेगा, यानी कि आपने x की जगह पर जो भी रखा होगा वो एज इट इज रहेगा. एंड यू हैव टू डिवाइड फाइनली फॉर a से आपको डिवाइड करना पड़ेगा. वी हैव टू सी कि हम ऐसा क्यों कर रहे हैं, एंड वी विल बी लर्निंग इट थ्रू एन एग्जाम्पल. लाइक ये मैंने क्या लिख दिया है, बट ऑलवेज रिमेंबर that this x should be x raised to power 1 only for applying this step. This is your second step. Like if I ask you to integrate, let's say I ask you to integrate cos x only, तो you will simply say कि अभी अपने को याद हो गया, तो integration of cos x is sin x because it is reverse process. तो इसका तो आपको पता है, but if you replace this x by some linear replacement, for example you write integration of cos minus 2x plus 3. So what you have done is you have replaced this x something like this. आपने उस x को linearly replace कर दिया है. So what you will find is this will be equals to sin of x की जगह पर जो भी replacement किया है like minus 2x plus 3 and then divide it by minus 2 at last. You have to divide with the coefficient of x. This is not possible if you have done something like cos x square plus 3. अगर आपने उसे ऐसे लिखा होता then you cannot integrate through this method because for this you need only linear replacements. दैट मीन्स आपको x की जगह पर x का ही कुछ लीनियर कॉम्बिनेशन रखना है, x का पावर 1 ही रहना चाहिए. ओनली इन दैट केसेस यू कैन अप्लाई दिस फॉर्म. फॉर एग्जाम्पल लेट्स से इफ आई आस्क यू टू इंटीग्रेट अ फंक्शन दैट इज समथिंग लाइक इंटीग्रेशन ऑफ 1 अपॉन 2x plus 3 dx. So what you will say is you will say कि 1 अपॉन x का जो इंटीग्रेशन था दैट वाज कितना था, ये log x. So if you have replaced this x by 2x plus 3, that means it is a linear replacement. So this will be equals to log of 2x plus 3. And then what we will do is we will divide this by coefficient of x which is 2. तो अपन 2 से इसे डिवाइड कर देंगे. Are you getting the point? कैसे इंटीग्रेट करना है इन द सेकेंड स्टेप? Great. So like if I ask you for the third one, and that is tell me for integration of cot 2x plus 3. For cot 2x plus 3, just remember if there was any function जिसे differentiate करके cot x आता था, there was no such function, we cannot apply any of the above steps. These steps are only applicable if the function that you want to integrate is from the results of differentiation. ये सिर्फ तभी अप्लाई हो पाएगा. Like if I ask you to integrate, let's say sin square 4x, there was no such function जिसे आप डिफरेंशिएट करके sin square x ला सकते थे. Just say no to such type questions. Yes, please ask. Sure. From this one, from this integration of sin square x, like from this step? Okay, so for cos x, like, no? Okay, so the basic of this step was, if you replace x by its linear replacement, अगर आप x की जगह पर ax plus b टाइप का कोई लीनियर रिप्लेसमेंट पुट करते हैं where a and b are constants, so integration remains same and you just have to divide at last by the coefficient of कोएफिशिएंट ऑफ x का जो कोएफिशिएंट होगा आपको उससे डिवाइड करना है लास्ट में. सो फॉर एग्जांपल इफ यू हैव अ फंक्शन cos x, तो आपको डायरेक्टली पता है इंटीग्रेशन ऑफ cos x इज sin x. But if you replace x by linear replacement which is minus 2x plus 3, this is a kind of question. Example ही है ये. तो if you integrate cos of minus 2x plus 3, so this will be equals to, it remains same जैसे cos x का इंटीग्रेशन sin x था, तो cos of minus 2x plus 3 का sin of minus 2x plus 3, and at last what you have to do is you have to divide by coefficient of x. Like here x का कोएफिशिएंट कितना है -2, तो you just divide it by -2. Just think, if it was cos x square plus 3, in this case you cannot integrate because your replacement is not linear. इस बार जो x का पावर है that is not 1, x का पावर 1 होना चाहिए to integrate. Then in the next step I asked you about integration of 1 upon 2x plus 3 dx. So if you wish to integrate, just think of this one कि अगर 1 upon x होता तो इंटीग्रेशन शुड हैव बीन इक्वल्स टू log x, लेकिन यहां पर क्या हुआ है, इट इज 1 upon 2x plus 3. That means what you have done is you have linearly replaced this value of x by 2x plus 3. So integration remains same, log 2x plus 3 divided by 2, because this is the value of coefficient of x. Similarly, if we write integration of sin square for x, there is no such function जिसे इंटीग्रेट करने के बाद sin square आ रहा था. That means we cannot integrate this. Have you got the point? Great. So we are left with so many functions. Like अभी ऐसा लग रहा है कि इंटीग्रेशन हम सिर्फ बहुत कम फंक्शंस का ही कर पाएंगे. ऐसे बहुत सारे फंक्शंस नहीं होंगे जिसे हम इंटीग्रेट कर सकते हैं. So we will have more methods to integrate now. Like one of them is trigonometric transformations. What it says is कि अपने को जितने भी स्क्वायर्ड फंक्शंस हैं, जैसे साइन स्क्वायर एक्स और कॉस स्क्वायर एक्स, इनके डायरेक्ट इंटीग्रेशन नहीं आते है ना, बट व्हाट वी नो इज वी नो हाउ टू कन्वर्ट देम लीनियरली. इफ यू रिमेंबर वी रोट सम इक्वेशंस लाइक cos 2x इज इक्वल्स टू 1 माइनस 2 साइन स्क्वायर एक्स, ऐसा कुछ हमें लिखा था. when we have derived this like cos a plus b के फॉर्मूले से in the trigonometric lecture. Similarly, if we write for cos 2x in terms of sine, तो ऐसा भी एक फॉर्मूला था. The equation was, you can write cos 2x as 2 cos square x minus 1. Do you guys remember about these equations? Great. So if I asked you to integrate what, let's say sine square x first, so you need to use trigonometric transformations, because स्क्वायर का तो अपने को नहीं आता है, बट वी हैव वन इक्वेशन जो कि स्क्वायर को लीनियर में कन्वर्ट कर देता है बाय सेइंग लीनियर, उसका पावर 1 है. दिस इज cos 2x, दिस इज अ लीनियर फंक्शन. तो हाउ वी विल राइट इट इज, हम इसे चेंज करेंगे एंड दिस विल बी इक्वल्स टू take 2 sin square x to the left side and cos 2x to the right side. So 2 sin square x will be equals to 1 minus cos 2x. So sin square x will be equals to 1 minus cos 2x, this is 2x, cos 2x upon 2. So you can write this trigonometric transformation here, and this integration will be transformed to 1 minus cos 2x divided by 2 dx, और अभी आपको इसे इंटीग्रेट करना है. What we can do is we can integrate it like integration of 1 upon 2 minus cos 2x upon 2. And you know that कि अगर ऐसे दो अलग अलग टर्म्स हैं तो we can integrate them individually. Please see one more thing, like we have practiced some questions on this equation which is x raised to power n. Just think if it was integration of 1 dx. So what it should have been, you can write 1 as x raised to power 0 because that means the same. And if you will do integration of this, so this will be x raised to power 0 plus 1 upon 0 plus 1. So this will be equals to x only. So integration of 1 is basically just x. So what we will do here कि जो again the rule which says कि जो constant है वो बाहर आ जाएगा, so that will be 1 upon 2, तो बाहर आ गया, and integration of 1 in this case will be equals to x only, minus 1 upon 2 again constant है, and if you wish to integrate cos 2x, so this is kind of a linear replacement कि आपने x को 2x से replace किया, so the function you will get after integration is sin 2x upon 2. Divide करना पड़ेगा 2 से, you have to divide by coefficient of x at last. Have you got this step? For this step please answer the last step. Great. So this is kind of integration x upon 2 minus sin 2x upon 4. This is your integration for sin square x dx. I hope you have got the basic idea like और ये चीज की कौन सा स्टेप अप्लाई होगा. I have told you in the beginning only that you have to check them in every case. Like you have to check for the first one, for the second one, for the third one and so on. आपको फर्स्ट चेक करना है, फर्स्ट से अगर हो गया तो ठीक है, अदरवाइज यू हैव टू मूव टू द सेकंड वन, और सेकंड से अगर हो गया तो ठीक है, अदरवाइज यू हैव टू मूव टू द थर्ड स्टेप which is this one, which is like trigonometric transformations. Have you got this? इसमें किसी को कोई प्रॉब्लम है? Okay, that's great. Then for the last method which is a bit complicated, बहुत ज्यादा नहीं है लेकिन थोड़ा सा है ना, तो please see this very carefully and do as many questions as possible so that you can remember it for the longer time. और एक चीज और, that these methods are going to help you till the last chapter of your class 12th syllabus. Like I don't expect if you are getting this in your school classes because they are like to prepare you for board exams, है ना? So you need to learn this and this will be very helpful for you in every chapter of your like till 12th class. ऐसे last chapter तक आपको हर एक जगह पर ये help करता रहेगा, this differentiation and integration, if you are really preparing for some good competitive exams. Otherwise this last method is not for your school exams. If you are preparing just for school exams, there is no need to learn this. You will be never asked questions based on this. But if you are preparing for JEE, NEET or such standard of examinations, then in that case you will have to learn this. So let's start with the last one, and this last step says लाइक इफ यू हैव डन एवरीथिंग दैट इज पॉसिबल, जितना भी आप कुछ कर सकते थे वो आप कर चुके हो. सो द लास्ट स्टेप सेज start finding differentiation. Please don't get confused in differentiation and integration, no? So I am writing it differentiation. Start finding differentiation of complicated function within itself. उसी के अंदर से कोई ऐसा फंक्शन ढूंढो. Start finding differentiation multiplied by dx. What does this mean is, if you are like given with 2x upon x square plus 4 dx, please see this very carefully. This is not of the form like which you can remember कि ये किसी का differentiation था, है ना? Because in most of the algebraic expressions we have only one formula, and that is simply for integration of x raised to power n, and this one is not of that form. So first step is like skipped, उससे तो कुछ नहीं होने वाला. To the second step, it is also not a linear replacement of that. तो second step से भी कुछ नहीं होगा. To the third one, it is not a trigonometric function. तो उससे भी कुछ नहीं होगा. To the fourth one, which is this, you have to find a function जिसका differentiation ये जो dx है इसके साथ multiply में लिखा हुआ है. For example, in this one, you have this x square plus 4. Like if you differentiate x square plus 4, you will get 2x only, because 4 is the constant और उसका differentiation 0 होता है. So you have to look for such a function. आपको ऐसा कोई function ढूंढना है जिसका differentiation dx के साथ multiply में हो. You can take as much function as you want. For example, in this case only, you can also consider only x square, because उसका भी differentiation 2x ही है. And once you have taken that, just write it somewhere else. For example, I have written and I have assumed this as equals to t. So t is equals to, let's say, x square plus 4. You have to look for such a function. Are you getting my point? Basically, sure. Basically, this t means nothing. This is the new variable. What I want to say is, if you have a integration जिसे आप डायरेक्टली नहीं कर पा रहे हैं, आपने ऊपर के तीनों स्टेप्स लगा लिए हैं, देन एट लास्ट स्टार्ट फाइंडिंग अ फंक्शन जिसका डिफरेंशिएशन ये जो dx वाला एलिमेंट है इसके साथ मल्टीप्लाई में लिखा हुआ है. तो मल्टीप्लाई में क्या लिखा हुआ है यहां पर? दिस इज 2x. तो यू कैन डायरेक्टली थिंक कि 2x वुड बी the differentiation of x square plus 4 or just x square also. दोनों ठीक है. So you have to look for such a function. Let's take one more example. अभी इसे solve करना हम सीखेंगे. First we have to see how to look for a function. Like if you are given with integration of, let's say, sin x cos x dx. तो जस्ट लुक फॉर अ फंक्शन जिसका डिफरेंशिएशन dx के साथ मल्टीप्लाई में है, तो आप सिंपली यू कैन से sin x इज दैट फंक्शन, बिकॉज इफ यू डिफरेंशिएट sin x you will get cos x, which is in multiplication with dx. Let's say if you are asked for integration of x square plus 4 raised to power 5 multiplied by 2x dx. You have to find such a function जिसका डिफरेंशिएशन dx के साथ मल्टीप्लाई में है. व्हाट इज दैट फंक्शन? 2x. तो किसका डिफरेंशिएशन होगा? अगेन एक्स स्क्वायर प्लस 4 का. तो जस्ट एज्यूम t इज इक्वल्स टू एक्स स्क्वायर प्लस 4. आर यू गेटिंग दिस? हाउ टू सी फॉर अ फंक्शन? हाँ, you can also take x raised to power 2. That is correct. You can also see कि x square का भी डिफरेंशिएशन 2x ही होता है. Both are correct. You can go with anyone. What you have to look for is just a function which is in multiplication with dx. और वो किसका डिफरेंशिएशन हो सकता है, जस्ट स्टार्ट फाइंडिंग फ्रॉम दैट इंटीग्रेशन ओनली. उसी के अंदर से आपको ढूंढना शुरू करना है. एंड वंस यू हैव गॉट दैट, उसके बाद दिस इज गोइंग टू बी एक्सट्रीमली इजी फॉर यू टू इंटीग्रेट नाउ. ठीक है. सो फर्स्ट स्टार्ट फ्रॉम द फर्स्ट एग्जांपल, देन वी विल बी टेकिंग दीज. तो for the first one we have taken this t is equals to x square plus 4. So basically what this means is that we want to replace these x in terms of t everywhere, and we also want to replace this dx in terms of dt, so as this function can be simplified. How? If you differentiate this t, what you will get is dt by dx is equals to 2x. Why we are doing this is we can get value of dx in terms of dt. We want this whole integration to be changed in terms of t. Now what you will find is if you take this dx to the other side, dt will be equals to 2x dx, and this 2x dx is basically dt. That means in numerator your equation was 2x dx, so you can write simply dt upon. Here you have x square plus 4. You can replace x square plus 4 by t, so you have t. So what we have done is we have replaced this whole function which was in terms of x, and now it is in terms of t. So this is simply integration which is log t. And at last we can also do that you can write this t in terms of x जो आपका पहले था, that was log of x square plus 4. This is your final answer. Just see the reason behind why we want कि dx के साथ उसका डिफरेंशिएशन मल्टीप्लाई में हो, because when you will differentiate we want कि न्यूमरेटर पूरा रिप्लेस हो जाए, और उसके बाद जो भी कुछ बचेगा that would have been replaced by these. Are you getting the point? किसी को कोई प्रॉब्लम है इसमें? We will be doing more examples. I know like it is not possible for anyone to understand this for the first time, but I hope you have got the idea like what we are doing basically. Basically, our motive is to change this complicated function into a simpler one using some another variable, but that should be equivalent to this one. वो उसके equivalent भी होना चाहिए और वो किसी अलग फॉर्म का भी होना चाहिए. तो what we are doing is we are changing our variables. Please ask if anyone wants to ask something in this step, then we will move to the next one. Not the next step, but the next example. Yes, please ask your questions. Anyone with any kind of question you want to ask? Okay, so great. Let's take some more examples. And let's say the example says integration of e raised to power x cube 3x square dx. You wish to integrate this function. So what you can do is you have to find such a function which is, if you differentiate that, उसका differentiation dx के साथ multiply में नजर आ जाए. So if I assume, please anyone if you can answer कि मुझे क्या assume करना चाहिए, anyone with any kind of answer, that may be wrong or right, but at least you should try. आपको इसी में से कोई ऐसा फंक्शन ढूंढना है जिसका डिफरेंशिएशन dx के साथ मल्टीप्लाई में लिखा हुआ है. Let's take x square. So if I take x square, which is t is equals to x square, let's say the differentiation of x square is 2x, but I am not finding this 2x in multiplication of dx. ऐसा फंक्शन ढूंढना है जिसका मल्टीप्लीकेशन जिसका डिफरेंशिएशन dx के साथ मल्टीप्लाई में हो. Very good, that's perfect. So if you have taken this x cube, so differentiation of x cube is 3x square, and that is in multiplication with dx, so that goes great. So this will be our assumption for this one, that t is equals to x cube. Now what we will do is we want this dx to be changed in terms of dt, and we want x to be changed in terms of t. So the second assumption will work, and if we write dt by dx, this will be equals to 3x square, and this will be equals to 3x square dx. So this 3x square dx can be replaced by dt. So in place of 3x square and dx, you can just write dt, and in place of x cube you can write t. So your function will look like e raised to power t dt. Are you seeing how we have like transformed this complicated function into a simpler one? ऐसे ऊपर थोड़ा खतरनाक सा लग रहा है देखने में इंटीग्रेट करने के लिए, और नीचे वाला फंक्शन विच इज इक्विवेलेंट ये थोड़ा सिंपल सा लग रहा है. The only reason why we are doing this is to make our functions simpler, and the procedure is that you can change your variables. This function and this function means the same because you have written this equation. It is only that the form which is visible to us is now a simpler one. That is why we are doing this. And now integration of dt, e raised to power dt is what? e raised to power t only. ये तो अपने को पहले से पता है. And in place of t, what you can do is you can write x cube. So your answer is e raised to power x cube. So integration of this complicated looking function is just e raised to power x cube. Is there anyone with any kind of doubt you have? Okay, great. So I hope you have got a little bit of idea how to integrate. For the last step, it is a bit complicated to find initially, but as soon as you start practicing questions, you will get that it is very easy for you to identify that which function we should assume. Okay, so start practicing questions based on integration. This was all from my side in this lecture. Thank you so much.